In this video, we'll look at question 23 from the 2016 exam. So in this question, we see three hypothetical or real scenarios of nuclear fission of a uranium-235 nucleus, which then decays into two lighter nuclei and some other particles. We are supposed to say which of these three is or are possible, which could actually occur. And what we'll do is we'll go through them one by one and count the atomic masses before the reaction and after the reaction, as well as the numbers of protons, because those need to match, right? If we have 236 lots of mass, or some units of mass coming in, then we have to have the same amount of mass coming out of the reaction. And that's all this question is about. We'll be just counting numbers. And already in the first instance, we see a mismatch. So the mass before the reaction, that means just the proton and the uranium nucleus, which together give us 235 plus 1 is 236, and the mass after is 144 plus 89 plus, and these are neutrons, so they have mass 1 plus 1 plus 1, and altogether the mass after the reaction is 235, which is not 236, and this is wrong. And a very similar thing happens in option 3, where again the mass before the reaction is 235 from the uranium plus 1 from the neutron, and the mass after is 3 neutrons, 87 and 145, which only amounts to 235. Again, a mismatch. This is impossible. No. Reaction number 2, however, looks much more promising. Again, mass before is 235 plus 1. And after the reaction, we have 3 neutrons, 137 from the xenon and 96 from strontium, which is actually 236. So hooray! The masses match. We should also check that the number of protons is okay too. So let's just do that quickly. It's 0 from the neutron and 92 from uranium. 54 in xenon, and strontium has 38 protons. And this indeed is 92. So everything is tickety-boo. So to conclude, only reaction 2 is actually possible in terms of conservation of masses and numbers of the elementary particles. And in the exam, that was option C, which was the right one to pick.